Hi everyone, today we're going to learn about complex fractions. A complex fraction contains one or more fractions in its numerator, denominator, or both. So basically it's a fraction within a fraction. So steps on how to actually simplify a complex fraction are as follows. You have to determine the LCD of all fractions and then multiply each term by the LCD and then finally reduce it. And the reason you're multiplying each term by the LCD is because you want to get rid of all the extra denominators so you end up with a single top and a single bottom in a fraction. Let's take a look at number 1. Number 1 is a complex fraction because you have a fraction on the top, a fraction on the bottom within an entire fraction. So we need to actually simplify it. So we need to get rid of those extra denominators, the 3x and the x. And the way to do that would be to multiply them by the LCD. Well, the LCD for 3x and x would be 3x. Okay, so you're going to need to multiply each term by 3x. Well, you only have one term on the top, so I'm going to multiply it by 3x. And since I'm multiplying by the original fraction, I'm going to make him a fraction by putting it over 1. Then I'm going to do the same thing to the term in the denominator. 1x is going to be also multiplied by 3x, and again, since you're multiplying by a fraction, I'll put him over 1. Now, if you remember, when we looked over how to multiply fractions, we said that we don't need common denominators, but we can cross-reduce. So in this case, on the top, 2 over 3x times 3x over 1, I can actually cancel out the 3x's. And on the bottom, I can actually cancel out the x's. So if you look at it closely, I actually got rid of all those extra denominators. So let's see what I have left over. 2 times nothing, well really it's 2 times 1 is 2, over 1 times 3 is 3. So I no longer have a complex fraction. I have a simple fraction with a single numerator and a single denominator. Now I ask myself, can that be reduced? And it can't, so there's my answer. Okay, let's move on to another example. Example number 2 is a complex fractions because you have fractions within a fraction. So I need to get rid of those extra denominators by multiplying through by the LCD. So let's take a look at all our extra denominators. We have an x, a 2, and an x. What do you think the LCD would be for this complex fraction? You're right, it's going to be 2x. So I'm going to need to multiply every single term by the 2x. Okay, so I'm going to multiply 1 over x by 2x, and I'm going to put it over 1 because it's a fraction. I'm going to multiply 1 by 2x, but in this case, I'm not going to make 2x a fraction because the 1 isn't a fraction. I'm going to multiply 1/2 by 2x and make him a fraction because it's a fraction times a fraction. And then 1 over x by 2x and make him a fraction. Alright, let's see what I can cancel out. On the top left, I can actually cancel out an x. On the top right, I can't cancel anything out because neither of them are fractions. Alright, bottom left, I can actually cancel out a 2. And bottom right, I can cancel out an x. Now if you look, all those extra denominators in that complex fraction have been canceled out. So that was the object of the game, so we achieved it. So let's see what we have left over. On the top we have 2 times 1, which is 2, plus 1 times 2x, which is 2x. On the bottom we have x times 1, which is x, minus 1 times 2, which is 2. Alright, now I have an actual single fraction with one numerator and one denominator. So now I'm going to see if I can simplify that fraction. Well, it looks like I can GCF a 2 out of the top and get 1 plus x. And on the bottom, I can't do anything. Can I reduce it any more? No, I can't even cancel anything. So really, the original answer I got was my answer because by factoring out, nothing canceled. All right, let's go on to number 3. All right, it's a complex fraction because I have fractions within a fraction. So I'm going to need to multiply every term by the LCD. What do you think the LCD would be for xy and xy? Hopefully you said xy, and if you did, you are correct. So I'm going to multiply every term by xy. He's a fraction, so it's going to be xy over 1. He's a fraction, so it's going to be xy over 1. He's a fraction, so it's going to be xy over 1. and he's a fraction, so it's going to be xy over 1. Okay, let's do some canceling. In the first term, I can cancel the x's. In the numerator on the right, I can cancel the y's. Let's go to the denominator. On the left, I can cancel the x's, and on the right, I can cancel the y's. All right, do you notice how all my extra denominators in that complex fraction have been canceled out? So we achieved what we wanted to. Let's see what our final answer is. Y times 1 is y, plus 1 times x is x, over y times 1 is y, minus 1 times x is x. I can't simplify it anymore, and nothing else can cancel out, so there's my answer. All right, let's move on to a little harder example. Number 4. In number 4, I have a complex fraction because I have fractions within a fraction. But if you notice, I only have extra fractions in the denominator and not the numerator. I'm still going to solve it the same way I did number 1, 2, and 3. So I need to think of an LCD that will get rid of the extra denominators. Well, my denominators would be x and x squared. The LCD for x and x squared would be x squared. Now, if you're having a hard time thinking about what the LCD would be, think of it this way. If you were going to take those fractions and add them together, what would you use as a common denominator? All right, so I'm now going to multiply every term by x squared. So I'm going to multiply the numerator by x squared. It's not a fraction, so I'm not going to make x squared a fraction. I'm going to multiply the 1 by x squared. He's not a fraction, so I'm not going to make that a fraction. I'm going to squeeze this in and multiply 5x by x squared over 1. And then 6 over x squared is also going to get multiplied by x squared over 1. Okay, let's see what we've got here. I can't cancel anything on the top. On the bottom left, I can't cancel anything. I can cancel an x for an x, so I'll get rid of that little squaring there. And then I can cancel an x squared for an x squared. So I got rid of the extra denominators. Let's see what I have left over on the top. On the top, I'm going to have x plus 2 times x squared. So I will end up with x cubed plus 2x squared. So I had to do distributive property. All right, on the bottom I have x squared times 1, which is x squared, plus 5 times x, which is 5x, plus 6. Okay, I no longer have a complex fraction, so I'm going to see if I can reduce this fraction that I have now. On the top, I can use the LCD of an x squared, a GCF of an x squared, and end up with x plus 2. In the denominator, I can go to two binomials, and it's an x and an x, factors of a positive 6 that will give me a positive 5, plus 3 plus 2. In this case, I'm able to cancel an x plus 2 for an x plus 2. So my final answer will be x squared over x plus 3. So again, after I use the LCD method to get rid of the extra denominators, I take my final answer and see if I can simplify it even more. I was able to GCF out an x squared on the top, and then do two binomials on the bottom, and cancel out the x plus 2's. So my final answer again is x squared over x plus 3. Okay, let's take a look at the last example. Okay, we have a complex fraction. We want to get rid of the extra denominator, so we want to multiply by the LCD. Now this one might be a little bit more difficult because it's kind of hard to see what the LCD would be. So what I'm going to do is see if I can actually factor out those extra denominators to see what I have. So I'm going to pretend like I was adding them. I can't do anything to x plus 6, but x squared plus 3x minus 18 can factor to be x plus 6 times x minus 3. So I'm going to cross this guy out and leave it as x plus 6 times x minus 3. So the LCD looks like it would be x plus 6 times x plus 3. I'm sorry, not x plus 3, but x minus 3. Let's erase that. Okay, you might say to yourself, well, why didn't we just use x plus 6 as the LCD? Well, if I would multiply the top fraction and the bottom fraction by x plus 6, the whole denominator in the bottom wouldn't cancel out. And remember, we're trying to get rid of all the extra denominators. So now I'm going to multiply the top and bottom by the LCD. So I'm going to multiply the top by x plus 6 times x minus 3 over 1. And I'm going to multiply the whole denominator by x plus 6 times x minus 3 over 1. All right, let's see what I can cancel. On the top, it's an x plus 6 for an x plus 6. On the bottom, it's an x plus 6 for an x plus 6 and an x minus 3 for an x minus 3. So now I've gotten rid of all my extra denominators, so we're going to see what we have left over. Okay, on the top we have 4x times x minus 3 will give us 4x squared minus 12x. On the bottom we have x squared minus 3x times everything else got canceled out, so it's x squared minus 3x. Okay, so now I'm down to a simple fraction. So now I'm ready to factor and cancel. On the top I can GCF out of 4x and get x minus 3. On the bottom I can factor out an x and get x minus 3. I can cancel the both x minus 3's. I can also cancel out an x. So my final answer here is 4. Okay, so today we learned how to simplify a complex fraction, which is our fractions within a fraction, by using the LCD method. I hope this is a fun topic for you just as much as I enjoy it, and I will see you in class tomorrow.